So good evening, everyone. Hope that your day has been educational so far. I know there's a lot of talks, so everyone should be learning a lot. And I wish to add to that. So I'm going to try to explain some ways you can use functional programming, functional concepts to reduce complexity in your code. So who am I? Jason. That's how you can find me on Twitter. This is where I work. Work for Razorfish. I'm a software developer there. And I've been doing this for about 14 years or so. And my first programming language was Cobalt, which is a procedural language. I might be dating myself by saying that. And for the last half of my career, I've been on the front end doing JavaScript programming. I absolutely love JavaScript. These are some of the projects that I've worked on recently. Walmart, LCBO, and Home Depot. And when you're working with large-scale applications, your code can get really complex because you have a lot of people working with it. It's a large code base because it's very complex. And when you're using an imperative style of programming, it doesn't help to make this easy. It creates some complexity. And I will go into some reason why that is and how we can tackle it. So the plot today will be the villain, the victim, and the victor. So how do we get there? I love this quote. The art of programming is the art of organizing complexity, of mastering the multitude, and avoiding the bastard chaos as effectively as possible. Basically talking about how the most important thing about your job as programmers is to organize your code so that it's easy to manage. This is a part of the villain, the code, the beast. I love this one even more. Simplicity is the prerequisite for reliability. And for our clients like Walmart, huge clients, reliability is the priority. They have to be up. So bug to code ratio. Who can tell me in the room how many bugs per 1,000 line of code on average for the industry? Anyone? 6? The answer is 15 to 50. So between 15 and 50 defects are found per 1,000 line of code. So this might lead you to say, if I write more concise code, I can have less bugs. So that's partially true, but we'll get into that. So maintenance costs consume about 40 to 90% of the entire project cost. So most of your time won't be spent on new features. It will be spent maintaining and fixing stuff. So this is how programming happens in the movies, and this is how it happened in real life. So our time is spent trying to understand code. This leaves no one happy, and there's usually 3 categories of people involved. The client, the developer, and your customers that are having a bad experience. They get annoyed because things don't work. But fear not, there's a better way. So there's 2 paradigms that we have to consider when writing code. There's the declarative style and the imperative style. Both can get the job done, but guess which one I'll choose? So imperative. So this is a long-winded quote or definition of the term. Imperative is a paradigm that uses statements that change a program state in much the same way that imperative modes in natural languages express a command. An imperative program consists of commands for computers to perform. Imperative programming describes how a program operates. So that's a lot of words. You can take that out, and this is really what it means. So we can contrast that with the declarative style. It's a style of building the structure and the elements of a computer program that express the logics of the computer without describing its control or causing side effects. And side effects are things that happen outside of your function or your statement. In React, it's a really hot topic. Probably most of the presentations you've been to have mentioned it. They're using a purely or mostly declarative style of coding. And this is really, really nice to work with. And if you ever play with React, you'd probably agree. So functional programming. Functional programming is not a new concept. It's getting a lot of hype recently, but it's not a new concept. It's been around for a few decades now. And this is how you can define it. Functional programming is a style of building structure of elements of your program. This is all taken from Wikipedia. That treats computation as evaluation of mathematical functions and avoids changing side effect and mutate data. You find in functional programming, and this is one of the things that I found, is they have a lot of big words for saying simple things. Like mutable just means that you can change the data. And so I don't know if everybody remember this. So this is Bill Gates back in 2001, I think, showing off a tablet PC. And this kind of reminds me of functional programming. You know, it was a great idea, but it was sort of before its time. At the time when Microsoft came out with this, internet connections were not as fast as they are now. They were pretty slow and sparse, and battery life was like crap. And what else was wrong? Multi-touch. We didn't have multi-touch. So without those things, tablets were bound to fail. That's kind of the same thing for functional programming. It was a really good concept at the time. It was an amazing idea when it was introduced with Lisp in 1958. However, the computers at the time were not like robust enough to handle this type of style of programming. So Lisp and functional programming also existed before its time. These are a few programming languages that are functional have functions as first-class citizens. Only one up there is a pure functional language, and that's Haskell. All the other ones have a mixture of functional style and objects and so on. And you'll find out that Haskell is a really awesome language, but it really is hard to deal with too. So it's not as awesome as JavaScript. So JavaScript is a multidimensional language. It can solve problems in many ways. The functional paradigm is nothing new for JavaScript, since it has been in there since its inception. So when it was created by Brendan for Mozilla back in the days, he had function built in. So I went too far. OK. So these are some of the concepts that I'm going to cover, functional concepts. Closures, higher order function, currying. That's actually derived from Haskell's last name, term currying. And recursion, composition. Composition is actually the sexiest thing ever. And we're going to talk about promise monads and memorization. So we'll get to them. So before we do that, though, I want to introduce the fat arrow. Some people might know about this. It's a feature in ES6 that allows you to write code shorter, to declare your functions a little shorter. I'm going to be using this in some of my examples, so just going to get you guys familiar with it. So this is how you traditionally would declare a function in JavaScript. There's other ways, but this is one of the common ways. You can take those things out and leave that, and it does the same thing in ES6. And that would be an anonymous function, one that doesn't have a name associated with it. And if you only have one argument, you can even take the bracket away. So you don't even need a bracket if you only have one argument. So this is a comparison between two functions that are two operations that does the same thing, but one is done in an imperative style, one is more a declarative style. What it's doing here, it's just taking a set of numbers and doubling them. So you can see it defines it, two variables, goes over a loop, and then it mutates the doubled array there by pushing the new numbers in. Get a mutation there. And with the declarative style, it's much cleaner, it's shorter, so less code, less bugs. And we're using a function that's on a method that's on an array called map to map over all the elements and apply that function to it. So when it goes over each element, it will take whatever number it is, it will be stored in n, and it will multiply n and by 2 and return that to the map function. It will create a new list without mutation of the result. And so you can do the same thing, much less code, much less room for errors. Closures. So closures is one of the amazing things that makes this entire thing possible. So I'm going to go through what is a closure. Closures are functions that refer to independent, free variables. In other words, the function defined in the closure remembers the environment in which it was created. So if you have a function and you have another function inside of it, that function can remember anything in there even after it was called. So we're going to see how that looks. So this is a definition of a closure here. So public foo, it's taking one argument, and that first variable, private, is after the function is run, is only can be seen by the closure. So that return statement there is defining the closure. And so to get that value, I can say return private, so on. So I can call that function and get that value in there. So that's high level. This is the closure part of it. So, so here's another example of a closure. This time it's not returning a function, but I'm returning an object that has three functions. Well, two functions. It's a counter. It's a little bit more useful. Here I'm counting up or down by calling the up or down method on my foo. But if you notice on the last line there, if I call foo.val, looks like I have a bug. Get 0 instead of the last number. The reason for that is if I just simply call it directly, because it's not in a closure, it doesn't have access to that value. So what it's referencing now is the original initialized value of 0. So we can fix that easily. So there's a problem. There's a solution. By just wrapping it into a function, I can call it, and now I can get the proper value. So recursion. So all you computer science people should know this already. I'm just going over it. This is just a review for you guys. Because we're going to be using it later. So recursion, the method where the solution to a problem depends on the solution to a smaller instance of the same problem. In other words, a function that calls itself. So here is an example of a recursion. So I'm defining a function here that can add a set of numbers. So basically, I check first to see if I only have, if my array is only one value, I'll just return that. Otherwise, I would take the second value, add the first and second value to it, use the shift method to delete the first one, and then call the add method again, which is itself. And so it will do the same thing over and over until it only has one left, and then it will return that. Is this clear to everyone? Yes, yes. No? Okay. Higher order functions. It is a function that takes a function as an argument or returns a function as a result. So this explanation, I think I found a better explanation on the internet. So we're going to couple higher order functions with recursion to take our previous function that we had and make it much more than an add function. We're going to make it a calculator function where you can do more with it than just add. So on the first line there, we're adding another argument, fn. And this fn will be the function that will be performing the task that we want. So instead of here where we have after the else where it says set the second element to be equal to the first element and the second element, that portion, that calculation there is going to be inside a function that we pass in. So you can see after the else there now, we can pass in whatever we want. We can pass in, what do we want, plus, minus, divide. So we're performing the same operation here by combining two understanding of functional programming. One is recursion, and the other one is higher order functions. We're passing in a function into a function. So on the left there, you can see where we pass first. The first thing that we pass is the set of numbers we want to work against, and then we pass in a function that does our computation. So here I'm just doing the same thing, just adding numbers. But because it's like this, because it's a higher order function, we can do some special stuff with it. We can do things like convert this to a reducer, where we can pass in any type of algorithm. So you can see I'm now multiplying or taking or adding or subtracting. I can do anything I want to those values there by using this style. So in JavaScript, natively, you have a method called reduce that does the same thing. So you don't have to write all this code. It's already there for you. Matter of fact, don't write this code, please. Korean. And this is not the Indian type. This We're talking about programming here. Currying refers to the process of transforming a function with multiple, I can't say this word. Arity. See, these are the functional guys here. The Haskell, the Scala guys, he has a Scala shirt on. And into the same function with less arity. Now, what is arity? He knows, but I didn't know till recently. But basically, what it means is arity is, of a function or operation is the number of arguments or operands the function or operand accept. Basically, how many arguments do you have? That's what that is. So if you have a function, it has 2 arguments. That's the definition of those 2 arguments, basically. So here's the magic that you can do with currying. I'm Jamaican, so got to put Shabba ranks in there. So here I have a function that returns a function that also takes an argument. So what I can do here, it's not really a constructor, but sort of constructor where I can define foodie there and add in my first argument. And then I can call foodie and add my second argument later. And then the 2 would be put together to create the result. So when I call it the first time with only 1 argument, it will give me a function in return. So I won't get any values back. It's just a function that has 1 argument that I can call again. But that isn't a proper currying because it only accepts only 1 argument. This is a better one because this can take any number of arguments. And this is a different implementation. You can see on the last line there, you can do syntax like that. Shabba also likes patties. Composition. This is the money shot right here. So composition can chain together functions to create new functions. So in object-oriented programming, typically you'll have an object and you can inherit from it, create another object, extend it, do all these things, which is great. And sometimes you need that. And I'm not for just doing it functionally only or just using composition only, because there's a place for object style as well. But sometimes with object style, you have this problem where you want a banana, but you get the gorilla with it. Right? But you only want a banana. Sometimes you get a kid with it too. Who wants a kid that's not theirs? So composition. So this is an implementation of composition where it takes, so arguments here is just, it's a native thing to JavaScript, line 2, where it gives you that for free. You get, if you call that, or that's just an array of any argument that is passed in. So you can define a function, not define the arguments, and you will have access to this that lists all the arguments that were passed in. And so we can loop over the set of arguments and basically do the composition. Yeah, welcome to composition. Okay, so here we're showing 3 different functions. One increments a number. You pass it a number, it increments it, add 1 to it. Second one just multiplies it by itself. Third one doubles it by adding itself to itself. So now if I want to do this awesome calculation, I can just put all these functions together and pass it to a new function. And it starts from the left, from the right, I mean. So what it does, it applies add, and then whatever the result of that is, get passed on to square. It applies square, and the result of that get passed on to double. And evaluate that, and then you get a return value. So if I put 1 in there, you'll get 8, because 8 plus 1 will be 2. 2 times itself will be 4. 4 plus 4, 8. You know, I'm not really running this in the console, but I'm sure it would work.
Why the last function first?
Why the last function first? Because my composition function works that way. But good question. Good question.
There is also a different example where you use composition, but you use it as pipe.
Mm-hmm.
Pass them in the order from left to right.
Yeah.
That's also another example that is out there.
Listen to this guy. He's a real. I'm a JavaScript guy. He's a Scala guy, way above my pay grade. Promise monads. So this is another big word, especially for JavaScript people, because what's a monad? Now, what's a promise? So let's talk about them in isolation. So a promise represent the eventual results of asynchronous operation. There's one thing that's common with people who understand promises. It's sort of a blessing and a curse, because when you start to understand it, you lose the ability to explain it. So I hope that I can break that curse today. So let's look at monads first, because we're going to combine them together later. So monads is the return operation takes a value from a plain type and puts it into a monadic container using a constructor, creating a monadic value. So what does that mean?
That doesn't help.
What does that mean? And this is, I'm telling you, these mathematicians come up with these terms. But what it means is that it's a certain type that I'm losing the ability to explain this. It's a certain type that is always returning itself. So for instance, a promise monad will always return a promise no matter what value you give it. So you give it a value, the result will be a promise that has certain properties on it, like a then and reject, and all these things that a promise type has, the characteristics of what a promise is. And so that's sort of what a monad is. It's a type that has a certain characteristic no matter the value you give it. So that's kind of the easiest way. And I'm looking to him for approval here. So in this example, I'm using the jQuery Ajax method to talk about this. Ajax actually returns a promise. So if you call $.Ajax, the result is actually a promise. Most people don't call it like this. They will pass in a success or a failure callback. But with this implementation, you get a promise back. And with that, you can do some awesome things. So here, I'm getting the top drinks, passing in my parameters to get the top drinks. And then there's another method here that will map over, not map, but filter. That's another higher order function we're going to talk about. What filter does, it takes a predicate. What's a predicate? Predicate just means a true or false, a Boolean. Just another fancy word that they use to say a Boolean. So it's a function that returns a Boolean, and if it passes, then it will be a part of the result. So I can use that to say go through a list of objects, check certain properties. If it doesn't pass, then it won't be included in the set that comes back. So you'll have a reduced set as a result of using this. So because I have a promise, it has this, this method called then. So what happens is this is sort of a callback. The get beer is sort of a callback. So I can pass that into my then statement, and what happens is when my round trip happens, when I go to the server and get my top drinks and it comes back, it would internally call get beer. And it will pass whatever value it got from the server to get beer. So when get beer get this drink selection, it can then do its stuff. You can map over it. And so all of this implementation will probably be hidden somewhere else, but your users, and when I say users, I mean your fellow developers, will be able to use this sort of like an interface. So they can say, get drinks, then do something else. And they don't have to worry about what's going on there. It's very clean, it's one line, less prone to problems. So one nice thing that you can do with promises, and this is not just for promises, but it can be used for anything else, is this idea of memorization. So, it's a optimization technique used primarily to speed up computer programs by storing the result of the expensive function calls and returning the cache result when the same input occurs again. So what that means is, if I should call the same service, or if even 10 people should call the same service, like really rapidly, they'll get back the same value. And so you can use this for instance, say you have a bunch of service calling this particular endpoint, and you want to catch something in flight. Instead of doing like, is it in flight, is it not? You can use a method like this to do it. And we'll show you the example here. So this is an example of how that would work. So remembering your promise. So you create this object. It's just a regular object. Call it memorize, but it's not really special. I'm using a closure here, and I'm defining a signature. What does my parameters look like? Because that is what determines what I'm going to be fetching. So I'm going to check. If I don't have that in my cache, I'm going to then save my result, which is a promise that's coming back from my AJAX call there. I'm going to save that to this signature, and then I'm going to return the memoized version. So if someone else calls, that whole if block will be skipped, and they will just go to the return statement. All right? So that's an optimization technique that you can use today. So the word for not function is this function. So go forth and function all the things. That's it.